just wanted to make a short little video, kind of lay out my thoughts on the upward vector being either a constant velocity or a constant acceleration. I'm not here to cause any division, muddy the waters, or cause or stir up any drama. I'm just trying to figure out the nature and mechanics of our reality. Let's think about how accelerometers work. Analog or digital, accelerometers detect or measure a change in motion. If the Earth is moving up at a constant velocity, objects in free fall are actually decelerating or losing momentum until the constant velocity of the Earth catches up to the object. Why are these decelerating objects not detecting or measuring any signs of acceleration? If accelerometers detect change in motion, acceleration, but do not detect a change in motion on objects losing momentum or decelerating in free fall, then on top of that, I use an accelerometer to detect constant velocity of Earth rising.
The idea of the upward vector is simply this. There has to be a force in the vertical domain. There has to be a force. For those who claim there's no force, that argument doesn't get off the ground. So that force has to be either in the downward vector or the upward vector. And only one of those is demonstrable. And believe it or not, as incredible as it sounds, the force is demonstrably in the upward vector. Now, there's a lot of ways we can go about to demonstrate this objectively with practical demonstration, but this is simply the way it is due to inertia and the way that multiple states of matter react when there's a change in motion. You can see this demonstrated when you look at multiple states of matter like water, air, and a solid. You can even look at it with a candle flame.
I'm just going to address something else quickly. We have factions of people who always come in and try and, cause factions between people in any given topic. Now, in this topic, we've got a faction of people claiming that the Earth's velocity must be increasing. It has to be an accelerating Earth reference frame. Okay? Now, these people have been addressed, and I'm going to make another quick point just to totally dispel these idiotic, silly, childish notions from people with incredulity and whatever other nonsense goes on in their mind. Now, if you have a reference frame, right? We'll just say it's the box, and this reference frame is going in that direction, right? And you're here on the surface of this. Now, these people that keep asserting that the Earth has to be accelerating, we'll get to the other aspects of that later on, but this is just to totally disband the idiotic notion that anybody can test for themselves. Okay? Now, if I have another reference frame, right? I have a little observer in there, and that reference frame is going at a constant, right? We'll say it's doing 100 miles per hour, right? That means that the reference frame, all its contents, you within it, are doing 100 miles per hour, okay?
If we have a reference frame, just draw the box like you did, with a reference frame going at 100 miles an hour this direction, and everything in it is going 100 miles per hour, like you showed. If he's going 100 miles per hour, the box is going 100 miles per hour, everything in it is going 100 miles per hour. Why is he at the bottom to begin with? If it's everything's moving this way at 100 miles per hour, what keeps him to the bottom of the reference frame? I thought that mass is a resistance to acceleration. If everything's going the same speed, there's nothing, he can't resist anything, because he's going the same rate as everything else. So he would, in my opinion, he would not have weight. He would not be pushed to this side of the reference frame if everything was going 100 miles per hour. There would be no force here. There would be nothing pushing on him. That's why there has to be an acceleration from the bottom. And acceleration is what gives you mass, like the resistance to acceleration, the resistance to change in motion. Like there would be no resistance. If everything is moving 100 miles per hour, there would be no resistance.
Now, in this scenario here, if I wanted to now elevate upwards at say 1 miles per hour in relation to the reference frame, I would now be, if I wanted to go at 1 miles per hour up the way here, right? What would happen is that as I go 1 miles per hour, the gap between me and the surface is going to increase, and I'm going to get further and further and further away from the surface. Okay? And that can be done in reality. I can move upwards at 1 miles per hour, and the gap between myself and the surface increases, and I will get further and further and further and further away from the surface. Okay? Now, if you're in a reference frame that's in constant acceleration, that being increase in velocity, right? So your reference frame has to get faster and faster and faster and faster and faster. Then me as the observer trying to move 1 miles per hour away from the surface, you would never achieve it. because you would have to be adding on the accelerated rate of your reference frame to your 1 mile an hour exponentially in order to get a distance away from the surface of the supposed accelerating Earth. Total and utter nonsense.
Are you saying that if you have a reference frame, so this box is the reference frame, it's accelerating at whatever rate, but it's accelerating, meaning faster and faster in velocity. So 9.8, 10 meters per second squared, whatever. Are you saying that if I had an elevator inside this reference frame, that it would not be able to separate from the bottom of the reference frame going at 1 miles per hour? Anything inside the reference frame has to be compared to the reference frame. The 1 miles per hour isn't compared to the acceleration of the reference frame. It's only being compared to in relation to the reference frame. So maybe I misunderstood what you were saying, but you can easily move at a constant rate inside of an accelerated reference frame. Whenever you move at a constant velocity inside of an accelerated reference frame, it is an acceleration. So that constant velocity does add to the acceleration, in which it makes it an acceleration. And that's exactly what we see whenever we're in an elevator moving up at a constant velocity. It is an acceleration. You're still at the bottom of the elevator as you're moving up at a constant velocity. Bottle of water, the water still stays at the bottom whenever you're moving up at a constant velocity. It's still an acceleration. That constant velocity is added to the acceleration.
Now what happens here in the upward vector? Now, if I've got two side-by-sides, right, and I move one at a steady rate, right, what happens is you get a steady pressure, you get a steady reading of weight, a steady resistance. Now if I take another one with a 1 kilogram weight and I constantly accelerate it up the way, I get a constant increase in weight, constant increase in weight, constant increase in weight.
Again, the people that are claiming acceleration, like Ken, he claims that the Earth is moving up, but it's constantly accelerating. So I don't know where the fuck he gets that claim from, because obviously our weight will have to be increasing, into infinity. Actually claiming that it's a constant acceleration. To me, they're either dumb as fuck, or they're literally deliberately just muddying the waters.
The weight as it goes up at a constant acceleration. Still working on some more tests with the stepper motor, but in the meantime I did a test basically just dropping a counterweight with a scale and a proof mass, an accelerometer also on the other side. As it goes up, definitely an acceleration, constant acceleration. How the proof mass does initially move up in weight, but then stays constant as it's still accelerating up. Definitely showing that the acceleration up does not continually increase your weight.
Constantly accelerate it up the way, I get a constant increase in weight, constant increase in weight, constant increase in weight.